Assalamu alaikum. How are you, dear student? I think you all are well. This is Muhammad Rafiqul Islam. Welcome to my class of my institution, Can Public School and College, Saidpur. Today, I will discuss derivative of function. Differential calculus is the study of the definition, properties, application of the derivative or slope of a graph. The process of finding of the derivative is called differential calculus. Now I am giving the general definition of derivative. Let y is equal to f of x be a function and 1. Let del x be a small increment of x and del y be the corresponding increment of y. So we can write here y plus del y is equal to f of x plus del x. This is 1. Subtracting 1 from 2, we can write here y del y minus y is equal to f of x plus del x minus f of x. Here y and y cut. Del y is equal to f of x plus del x minus f of x. Dividing both sides by del x, f of x del x minus f of x. Taking a limit del x tends to 0 on both sides. Limit del x tends to 0. Here limit del x tends to 0, f of x plus del x minus f of x by del x. Here limit del x tends to 0, del y by del x. This is denoted by dy by dx. Dy by dx is equal to limit del x tends to 0, f of x plus del x, f of x by del x. Replacing del x by h, replacing h by del x, then we get here dy by dx is equal to limit h tends to 0, f of x del h minus f of x is equal divided by h. This is the general definition of derivative. Equation 1 is called the derivative of y is equal to f of x with respect to x. For finding derivative of any function by the first principle, this definition is used. Now I will find some derivative from first principle. uh, 9c, differentiate a derivative from first principle with respect to x. I am solving here. A is sine 2x let f of x is equal to sine 2x. So f of x plus s will be sine 2x plus s, that is sine 2x 2s. According to the definition of first principle, we can write here d by dx f of x limit s tends to 0 f of x plus s minus f of x is. We know f of x is equal to sine 2x, so d by dx sine 2x is equal to limit s tends to 0 sine 2x plus 2s minus sine 2x by s. We know sin c minus sin d is equal to 2 cos c plus d by 2 sin c minus d by 2. Here we see the form of formula sin c minus sin d. Sin c minus sin d, sin c minus sin d, this is equal to 2 cos c plus d by 2 sin c minus d by 2. Limit h tends to 0. Using this formula, we can write 2 cos 2x plus 2h plus 2x by 2 sin 2x plus 2h minus 2x by 2 divided by h. Limit h tends to 0, 2 cos 2x plus 2x, this will be 4x, 2h by 2, 2x minus 2x will cut, sin 2h by h, that is sin h by h. Now limit h tends to 0, 2 cos 2x plus h multiplication limit h tends to 0 sin h by h. If we put here h is equal to 0, then we get 2 cos 2x plus 0, and we know here limit h tends to 0 sin h by h is equal to 1. So 2 cos 2x. So the derivative of sin 2x will be 2 cos 2x. Use first principle. I'll find the derivative of another one here. Two if f of x, suppose let f of x is equal to e to the power 2x. So f of x plus h, this will be e to the power 2x plus h, that is, or we can write this is exponential function e to the power 2x into e to the power 2h. According to the definition of first principle, we can write d by dx f of x limit h tends to 0 f of x plus h minus f of x by h, or d by dx at f of x, this will be e to the power 2x limit h tends to 0 f of x plus h, this will be e to the power 2x e to the power 2h minus e to the power 2x h. Limit h tends to 0. If we take common e to the power 2x, we get e to the power 2h minus 1 by h. Here e to the power 2x, if we write and limit h tends to 0, e to the power h minus 1, we can write here this is the exponential function e to the power 2h. We know e to the power x is equal to 1 plus x by factorial 1 x square by factorial 2 x cube plus x cube by factorial 3 plus x to the power 4 by factorial 4 up to infinity. Using this formula, we will expand this e to the power 2x at 2h. And e to the power 2x limit h tends to 0, 1 1 plus 2h by factorial 1 2h square by factorial 2 2h cube by factorial 3 dot 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 minus 1 at h. This will be cut. E to the power 2x limit h tends to 0, this will be 2h square by factorial 2h cube by factorial 3 dot infinity h. If we take common from numerator h, e to the power 2x limit h tends to 0 at 2 4h, this will be 4h by 2 factorial 8 h square by 3 factorial, because I have taken h common from numerator. So h here 2 4h square, then if we take common h, we get here 4h, similarly 8h square, here factorial 2 factorial 3 divided by h. H and h will cut, limit h tends to 0, we get here 2 plus 4h 2 factorial 8h square factorial up to infinity. If we put h is equal to 0, here 2 plus others term will be 0, and we get here e 2 plus e to the power 2x. This is the derivative of e to the power 2x. Dear student, you will solve some derivative using first principle like this process. Thanks for watching my class.